So I want to continue the presentation um, to show the demo of the product. This is the login screen. It's the data as of platform, airport master data management, and you will see a lot of the AI capabilities, including including several agents for some of the important functionality, and also eventually it's going to be exposed through MCP clients. So we'll demonstrate both the data time travel as well as the metadata time travel. But in this video, I'm going to focus mostly on the metadata time travel. Okay. This is all about, this is a multi-tenant software. So I have something like 10 companies. I'm simulating an enterprise company, Fortune 50, retail companies like Walmart, Kroger, and all of that. And also like two regression companies, which is ABC underscore corp and 123 underscore. And there are different personas, modeler, regular user, integration, and an admin. Okay, I'll log in as each one of them and then I'll show you. First, let's log in as modeler, which is where I'm going to focus a lot of my time on. Um, as you can see, this dashboard is like preliminary. It needs a lot of work. So you have a profile um, where it shows the modeler and what are the roles this person has and the company and all of that. And you can change the details and you can upload a profile picture. And then if you go back to dashboard again, this is the metadata management. We'll spend a lot of time here. Then there's a bunch of agents. I have about 10 agents. Um, like most of the functionality here is supported through an agent. And then this is the data time travel. We may get a sneak preview in this video, but it will be a separate talk about that. Then the data integration setup, like connection, data sources, and all that. Okay. Um, so let's dive in. Okay. So the fundamental notion of this product is the version. Okay. As we saw, version is a monotonically increasing object. It has got a name, a number, which is a monotonically growing, and description and what time it is got created. Okay, and so I could have shown the entire sequence of version, but it's not very interesting. What I'm showing here is what are the versions used by different dimensions. The bill of material dimensions happen to use 13 versions, okay, spanning from the March of this year to October of last year. Employee dimension, on the other hand, um, goes from July of this year to again October of last year, okay, and so on. Okay, that is this, and you can see it's a descending order. It starts with version 0, and that's something useful to do. What versions, and goes all the way to version 22. Okay, so let's look at the dimensions, right? Being a modeler, you have an ability to do a create. Right now, most of the authoring happens through the API. I'll show that API in a while. There is some amount of UI work that needs to happen, but that will come. But the API is fully functional. That's how I created this model. There are about 6 dimensions, and each dimension has got a set of hierarchies. Employee dimension has 8 hierarchies, and so on. So the taxonomy is the dimension. Dimension contains set of hierarchies. Dimension also contains set of members. The members can belong to multiple hierarchies. And then there is a property which can be tagged with either member or hierarchy or relationship and so on. Edges are between two different members of an hierarchy. Between the same two members, you can have different edges in different hierarchy with a different property, for example. Okay. And also, as we saw in the previous presentation, it's a directed acyclic graph. We support multiple parents, which are very important for a lot of application. So this is, even though I'm emphasizing time travel, from my 20 years of experience in the industry, this is one of the best metadata management capability. I've addressed all the pain points I've seen over my life, and I've addressed all of them in one single shot. Okay, because I'm building it from scratch. There's no point in doing it in version 2, 3, or 4. Like, yes, so all the design. So it's important to design properly in the beginning. That's what I've done. Okay. Let's go into hierarchies. So you can so for bill of materials you have two hierarchies. Looks like there's a bug, and I need to update the created by. These are created at different times. And then employee dimension has got many hierarchies because there are a lot of these test one, because I've been testing effective dated and rollback, and I'm going to demo that. So there are 8 of them. Okay. And time dimension has got 2, fiscal and calendar, which we saw in that theory presentation. Okay. And then there is a way to create it in the UI, but I did most of it through the API, which I'll show it at the end. Maybe I can give you a sneak preview. So this is the Swagger documentation. Like, it's pretty comprehensive. There is a lot of, it's connecting to a backend Spring Boot. There are quite a lot of them. It's difficult to read. Let me break it down by search by version. So there's a version management. This is how you can get all versions by dimension, max versions, version by hierarchy, and so on. And um, there are two different these things do two different things. Then the version dimension, you can create, delete, and get a dimension list, version hierarchy, version properties, query all, and all properties, all versions. Relationship is where you can query by queries sibling, descendants, children, roots, ancestors, and whatnot. CRUD is where you actually create the relationship between the two edges. Okay. There's a, so just give you a quick preview. The one that I walked you through in the theory presentation. So this is how you create a version. The bill of material dimension. You do this, and then you create a version hierarchy. You specify the dimension, and then you can create a member, like create member. You can create a multiple of this finish code 1, 2, 3, like this. Okay, and you can create an edge, like um, you are creating it as add as a new root, then add as a child, subassembly one you are adding as a child of fg1, and so on. Similarly, if you go into employee hierarchy, so this is how I created calendar year and all of that. We go into employee hierarchy. um, you creating the first root. John is the first employee, and Margaret, Edward are added as a child of John, and so on. Okay, and then if you remember, we also did um, so move to new parent. Like, now Ashley is moved to a new parent with the children. Okay, um, the yeah. So no, Walter is moved from Stephen to Ashley. Okay. Similarly, you can also move without children. Olivia is moved under John without the children. Those are all the things I showed you in that. If you remember in this PowerPoint, um, like all of these moving without parent and all of that. Okay, so everything is executed through this API. Okay, now let's go back to the demo. Okay. Um, so this is the two hierarchies. Let's jump into relationship, which is the most interesting one. Okay, if you go here, so bill of materials, let's go to bill of material hierarchy. Let me go to version 1. So this is, so M means modified. So in this version 1, these two are modified because FG1 has added as a child of virtual root, and the 1 signifies how many children are there. Now let's go to version 2. Now in SA1, SA2, and SA3 are added as a child of FG1. Okay, that's why they're all in yellow color. Okay, let's go to, so now the blue color means it was not modified. And now part 1 and part 2 is added as a child. So now we can see we are flying through time. So how easy it is to travel in time to look at the hierarchy. Now I can go back uh, and forward however many times I want. And I'm going to add an enhancement to this where I can see the same thing. I can show it as a two different React frames where you can independently adjust them and look them side by side and so on. Okay. And while we are doing that, we can also take a look at the audit log. This is the crux of it. Okay. I keep track of every changes. You can see whatever was shown in the graph view, P1 and P2 are added as a child of SA1, D3 added as a child of SA3 is clearly marked. SA1 as a parent, P1 as a child. I maintain two edges. It's important to maintain two edges because when you move it, the updates are easier. Okay, and this happens in this particular version. So yeah, because if we know FedRAMP and all auditing is a compliant, which many of my companies I worked in didn't have it and they have to retrofit it. But I know all of that, so I've been doing from day one. But this is also is helpful. So how is this highlighted? It's using the audit trail. Looking at the audit trail, when I render the graph, I know which nodes and edges I need to highlight. Okay. Um, so let's we can see here FG2 is added, and if you remember, that's what we did here. FG2 was added in version 4. So exactly what I showed you here was what I coded in the API, and that's what you are looking at it here. Okay. In version 5, this thing changed and so on. Now we can similarly you can take a look at the alternate hierarchy. Alternate, it goes back to when is the latest for that. If you go back in time, the next thing the change happened was in 7, 11, and then in 10. 10, so before that, there is no changes here, so nothing to show. Because that hierarchy started happening from version 10. So these three got added, and if you go and look in the audit log, and that's what you see. Okay. What do we see in table view? Table view basically gives you more interesting one in the sense if you go to BOM hierarchy, and if I look at FG1 to SA1, you can see here now this shows you the property. The 3.5 was added in version 8, but it got ended in version 9. In version 9, we changed it to 4.5. This is what I meant by LinkedIn profile in my, you can, and you can also see the audit trail, all the changes that happened here. Okay. And I also have this is the first AI demo. There are many of them. I'll show you this. So if you look at it, it's going to take a few seconds. It is submitting all of these to, this is one of the simplest invocation of LLM. I support, you can see it's generated. Um, it's basically showing when the relationship started, timeline, and then property changes. It gives you a nice English summary, particularly when it's here it is more focused, but there are other places where the summary is. When I go into member, you will know when a member has gone made multiple hierarchy changes over, let's say, 10-year period. It will be nice to get a nice summary over it. I'll do a demo of one of that. Okay. Um, and now let's go into time dimension. Um, time dimension. Let's look at the graph view. If we go to the version 0, these three are added. These three calendar year, and then all the quarters are added, and then all the months are added. Then why is it nothing showing up? Because the graph is too big. So we don't know what it is. But you can go take a look at the audit log. Okay, what did we add? Oh, we added uh, year 2018 and fiscal year 2018. Okay, so which means if you keep going to the right, you can see those two changes. Okay. So combination of that will be is pretty useful. Then there is a member view where the graph is, at some point this graph is going to become too big. Member view is where I'm going to go next. You'll be able to see a lot better. Okay. Same thing with respect to, there's nothing much interesting. So let me go into implied dimension. This is one of my favorite. You go to version 1, John, and then these three got added. If you remember from the other presentation, they're all marked as modified. Then their children get added, Ashley get added, and so on. So we can, so you we take, so this is unbelievable. I mean, when I first saw this getting built, I was mostly working on the back end. When I built the UI, it's beautiful to see it that you can fly through in time. Okay, um, it's I mean, it opened up so many ideas for me in terms of like looking at it this way. Um, it's very interesting. Now let's go into members. Okay. Member, so what's the difference? So the edge is, of course, the relationship between two members. Member is by itself. Okay. Now we are looking at this member. What is interesting to see? Let's go into implied dimension. I know there's a member named uh, Amber, who went through a lot of organizational changes. Let's look at her. Okay, you can see she is a leaf, so it's only one parent. If you look at the if you look at the property history, she got salary set in. I mean, in my API, kind of, I set the property only from version 26. That's how my client program. That's why it shows that. But higher date again, I made a change. Okay, 26 to, and then I again changed it. But this is an important one, which is the system defined property, which I explained in the presentation. So this is automatically created, not programmatically set by the customer. So what this says is Amber came into existence at version 7 and she left the company at version 12. And then again she rejoined in version 16 and then left in 27. Okay. That's what this thing says. Okay. Um, so and then audit trail show the same thing. You can see so number of changes here, and here the AI summary would be very interesting. And the graph, so this is more interesting graph. It just shows the view of that particular member instead of looking at the entire graph. I would expect customer to be spending a lot of time in this UI, like explore every member. You can spend enormous amount of time, all the members across all the dimension, all the hierarchies, all the properties, everything you can explore in this. It gives you a very comprehensive way of graph, audit trail, property history, as well as the details like how many children. I'm going to add more to it here, but so now let's generate all of these is fed into AI and it's going to generate a summary. Okay, so it's kind of a, so I've been experimenting with chat, the OpenAI, Anthropic, Gemini. I haven't played with Grok and DeepSeek, um, but as you can see here, it's pretty elaborate. Okay, the the tour of duty was 7 and then updated to 16. Employee profile information, including the first name and last name. um, Amber experienced three changes. Initially, she reported to Olivia, then she reassigned to Stephen. After deletion, reactivation is placed under Gloria. So, this is what I meant by automatic LinkedIn profile. Okay, we can get the complete lineage of any member in any hierarchy pretty easily, and it's driven by strong APIs. Um, and it's pretty powerful. Okay, now let me go into um, rollback hierarchy changes. Before I do that, I know I don't like to show SQL, but it's important to show I claimed order of n plus k size. Like, why is that? Because if you look at this one, the version edge is where I store all the relationship. If you look at this for Amber, I only show Because Amber is in multiple hierarchies, okay, and in fact I can even uh, um, so or I will show you the other hierarchy also. You can see there are multiple versions, and it is not completely cloned. Okay, every edge of Amber is not cloned. Amber only has those edges where the changes happened. Like she was first reporting to Olivia, then she started reporting to Steven, then she started reporting Gloria. Only those edges are stored. That's why it is order of n plus k. Okay, so the query is what's the dimension name, what's the company name because it's a multi-tenant, and what's the end member name where there's a start and a end. Okay, um, where she's the end because there will be a it's a twice actually if you so there will be a same copy of it with Olivia that is also so stored separately. Okay, so that's basically it's because it's constant. It's still order of n plus k. Okay, and then I also want you to remember this. If you, I'm going to do a new demo. How many hierarchies are there in this company? There are 16 of them. And then if you come here, how many edges are there? There are 88. Okay. The reason why it is important is when I create a new rollback in employee dimension, I want to say, okay, you have, let's go to the next one. How many versions are there? Up to 32. Okay, whatever reason, I want to, all these things are corrupted. Let me go back to version 9. Okay. I come here, I'm going to call it employee undo to version 9. Okay, that's it. And then let me, before I do that, if you remember how many things are there, 16 and 88, 16. Okay, so now let me create a new hierarchy. Okay, we go back here, employee dimension. Um, yeah, and undo to version 9, it showed up. There are 9. Okay, let's go and uh, the 16 should be now 17, 17, right? So roll back to 9 should be somewhere here. Okay, here. Undo to version 9. The edge is still be 88. So this is what I meant by undoing is even there are two benefits. So undoing still, so when I first created this, you can create however many you want. You can create hundreds and thousands. Okay, so if you go back, there's a source hierarchy. So this new hierarchy still refers to the, because all the changes happen in the historical or read only. Okay, they are never going to change because any changes are created as a new version and all of that. So that's why it's almost like a Git, right? So there is no cost to creating a new effective error. You can create hundreds of them and then play with it. Um, so similarly, effective data hierarchy. So what's the difference between these two? These two is this one, after you do an undo, okay, to a specific version, you can pick selective changes. This is why it's a multi-select. Okay, I undo to version 9, but I like changes in version 17, 18, 19 or something like that. And it's complicated, but I want to support that because sometimes there may be use cases where it's needed. This is like an hammer looking for a nail. I know it's a powerful capability. It's not completely working, that I'm in the almost at the point of getting it working. But I'll look for an application later on. But being able to roll back and selectively apply, I think it's going to be pretty important because I've done that in when I write code, right? Roll back to something and selectively merge some changes. So the effective data hierarchy is pretty simple. You go back here and simply use the latest version. Why you want to do it? Because your production hierarchy, or you don't have to do it if you unselected it, then you can pick a version. You can then pick as of certain time. Most of the time, what you want to do is you want to clone the current production hierarchy, and you want to make your own changes, like a sales manager want to do four different what if on the territory assignment, okay? Or you want to introduce a new bill of material design. So you can play with your hierarchy, okay? The last thing I want to show you is the audit trail. Audit trail is one of the important one. This is, you can see there are 172 entries here. If you go to employee, there are almost 368. And so this is like a, auto select. If I select three characters, it goes and searches in the backend. It found Amber. Amber is again the most complicated person. She has 31 changes. We got created in version 7. The tour of duty was automatically added at 7. And we added Olivia as a parent. And so this is the dual edge I was talking about. Olivia as a parent and Amber as a child. And uh, um, then Olivia moved to a new parent. So Amber got removed from her. Amber then got added to Steven. Okay. And then Amber got deleted. So she got removed from Steven. Okay. And then you can see the Amber got deleted. And then we removed the tour of duty property at 7. And then member was deleted is rejoined in 16. Okay. That I'm able to recognize that. And then now it is active, then we create a new tour of duty property with version 16 and so on. Okay. So you can, this is again the LinkedIn profile, right? The complete lineage, like similar to our lifeline, it's a slowly changing dimension, right? Unlike transactional data, which changes every millisecond, the hierarchical changes are a critical business event in a company. They don't willy-nilly add a new employee or a new cost center. Like it happens slowly. Though almost all enterprise companies have either one-off solution. No one uh, has a generic purpose. So I can give this to any customer if you use this platform. So slowly changing dimension, time effective hierarchy, version specific hierarchy, undo, audit trail, all of these are available out of the box for any customer who want to use this platform. Okay. Now let's go into agents. Okay. Most of the things you have seen are now available as an agent. So I've implemented the agent using LangGraph um, methodology. I'm using their library. Originally, I was going to code it in Python, but then it is difficult to. So let's go into MDM agent. It recognizes the fact that it's a modular role and you can query dimension hierarchies and all of that. And you can all of these children of, parent of, siblings. You can also, because it's a modular, you can also create new artifact. Okay. So you can see that it's also, you can use instead of version or you can use time. So internally there is a workflow within the agent which first it doesn't know all the API takes version object, but the first time is converted into version using the version API. Then it turns around, comes back to the agent, then it builds the payload for the other API to actually call it. Okay. So for example, if you say January 4th, the descendant API doesn't take January 4th. So you need to find what is the version at January 4th. So I will have another video where I will go through the implementation detail in depth, how the agent is implemented and all of that, and also the backend implementation, and you will be able to see all of that. Okay. So without, let me show you a demo. Okay. Um, let me start with something simple. Focus quotient. Okay, there's something important going on when I say let's focus on employee dimension and hierarchy. Okay, so I have to tell you, like if I run um, um, so you can see this is really nice, right? I'm pretty happy with how this UI. The moment I set this, the LLM is able to figure out, oh, okay, you want to set a working context, dimension name, and immediately it shows the view with the latest version. Okay, so now I can ask the question on this. Okay, now I will ask the question. Um, um, who are the children of? John in January 6th. So here, um, like I told you, if I can show you the Swagger API, January 6th is it doesn't take the time. So the agent is smart enough based on my prompt and all the tool functions that he needs to first find out. So it found out January 6th is version 7. Okay. Not only that, the graph automatically switched to version 7. So here, if you can see, there is no highlight here because there is no audit trail. There, I was on the client side, I'm using the audit trail to highlight it, but you can go back and forth here. So it's able to figure out version 7. And then for John, it also, I didn't say here employee dimension and employee hierarchy. It knows from the context. Setting the context is also pretty challenging. And I built using LangGraph library, I built its memory and all of that. They have an in-state protocol that I'm able to populate that, and it's able to find out Margaret, and it also gives more children. Margaret has two children, Edward has no children, and all of that. Okay, and you can do that. Now let me ask another one. Who are the descendants of? Instead of calling children, I can say who are the descendants um, of Stephen on July 3rd. I don't know what version it is, but it will find out. Okay, it found out it's version 21. It automatically switched the graph here, and you can explore the graph by moving around. Direct children at level 1 is these 4, and the grandchildren are these 2. And Stephen, there are 6 descendants, 4 direct and 2. It is beautiful. Okay, so here this is a kind of a crapshoot little bit. I'm using Anthropic, which is really good. Gemini, I sometimes these things fail. I have a multiple retries and all of that, but it's getting better with every month. And then OpenAI is also equally good, but Anthropic I found to be really, really good. But the more expensive version, if I if I if I go to my so I've tried all these questions. If I run this entire question, it cost me $36. Okay, so it's pretty. Uh, they make good money out of the API usage. Okay. So but it's amazing, it works really well. Okay, now let me try more in the focus question. One other thing I want to show you is, okay, now I want to show you, okay, now let me switch to, and switching context is another concept. This all required some work. I'm switching now context to another dimension and another hierarchy. So you can see when I asked about John, I didn't again say the hierarchy and all of that. It automatically directly said, and then the graph changed to BOM hierarchy. Okay, not only the bill of material dimension, but the specific hierarchy. Okay, um, member has been cleared and all of that. Okay, the previous context, all of that have been cleared. Okay, that's beautiful. So now let me ask this question. Who are the children of FG1 in February 22? Again, it will look up the version. Okay. Subassembly, you can it shows nicely. Okay. And I also figured out that date is version 9, and you can validate in the, I have the version UI where you can go validate it did the right thing. Okay. That's about that one. So let me one other thing I want to do is, instead of typing it one by one, so I created this functionality where I can upload the file. Okay. Okay. So this doesn't do all this does is, so it goes line by one. It's creating a version called time travel demo to world dimension and time travel demo to world hierarchy. Okay, it's creating a dimension like that. So it created that, and then there is nothing happened there. So it's a version 0. Now I'm saying create 3 members one after the other. with territory 1, 2, and 3 in the new version. In a new version means it knows it needs to bump up. Okay, it was 0, so it's very subtle. So now it created version 1. It's because now I'm saying create 4 more members, but here I am not saying bump up the version. It will again create it with the same version. So you can see the default property, which is system property of 1, was marked for all of these because they're all have tour of duty. They joined at version 1. Okay, there are 4 more members which will get created. Why this graph is empty? When you just create a member, there is no relationship, so the edges are not there. So for now I'm creating additional members 9, 10, 11, and 12, 13. Let's see whether it works. Sometimes these, when I do it in this sequence, I don't know, because of sometimes they fail. Okay, I've tried with all the LLMs, but it worked here. Okay, so now I'm saying increment the version, and this is the first time I'm creating an edge. I'm making territory 1, 2, and 3. Now the graph will show up in version 2. um, you can see now they become children of the virtual root. Now I'm saying in a new version, so version will be bumped up. Now 4 and 5 will be added as the children of territory 1. Okay, that will be version 3. Now you can see how I'm not only I have an API, I have AI driven methodology to create this time travel experience. Okay, and you don't need to have all the knowledge. The modelers can play with this and build the hierarchy. You can see how I'm slowly building the hierarchy. You don't have to have any knowledge of my complex JSON payload and all of that. You can build an hierarchy. I mean, LLMs are pretty good. They're very forgiving in terms of spelling mistake and so what I've done so far is I keep building up the hierarchy, adding different. We can take a look at that. So then it will start, then add territory 2 and 3 as the children after 7 and so on. So uh, uh, whenever it says bump up version, I'm trying different synonyms for incrementing the version, and it does a pretty good job. Now I start querying it. In version 3, find children of territory 1. Okay, it will go back in time, and so it's able to find that, and we can validate that once this is done. And so it's going to, I'm trying different question in version 3, in version 4. um, uh, we can validate all of that once it is done. Okay, so this is, and finally I also have something called write a summary of all the things we did. It creates a nice thing, and then you can email and whatever you want to do with it. Okay, it understands the notion of roots. The roots, you can see it says 1, 2, and 3. Descendants, um, whenever you say some specific version, the graph will switch to that. It's able to now see direct child, indirect child, and all of that. Find parents. How many questions are there? I think we're almost at the bottom. Okay. Ancestors. So I tried all combination, descendants, ancestors, roots. Okay, now create a summary or report of all the work we did. Okay. Um, it's going to write a nice summary. You can take a look at. So all these we built just by talking. Okay. You didn't need to know the API, and it is pretty good. I mean, you can see here it sent a nice summary. We created this dimension. dimension name, current version is 4, creation date is, I don't know why it says November 30. I guess um, uh, territory 1. It's got these children and it shows the structure beautifully. Okay. And you can believe me that the queries are right. Okay. So maybe I'll create a part 2 of this video and I'll stop here.